Water is never, ever actively transported. So that rules out 3 of them right off the bat. Water is never moved with active transport. Water is always a passive process. So A, B, and E are not correct because all of those use ATP. And then if you recall from our group work, we have simple diffusion and facilitated diffusion are the 2 ways that water could cross. Simple diffusion because individual molecules can shimmy across that butter membrane. And then if we really want to move water, we put in an aquaporin, which is facilitated diffusion. You're pale today, are you okay? Or are you just without makeup? See, this is why it's either wear makeup 100% of the time or never. So you don't get your instructor going, oh my God, honey, are you okay?
Yeah, that's what everyone does. See, come on, no, this is just my face. Just have a look.
All right, C and D then are the correct answer here. All right, now we start chapter 7. Now in this case, I've written down there what's wrong. I'm reminding you back from the first chapter. We have our feedback loop. All right. It's asking, in this case, our controller is the central nervous system. So, what kind of neurons are these? That's the question. So this notice, because I added a bunch of stuff that would have been critical thinking. Going into the central nervous system tells you it must be sensory. Going into the central nervous system. So that into, I just explained to you. So you didn't have to think about it. And then, what kind of neurons then are bringing information into the central nervous system? And we have already used these terms. We use those terms, in fact, when we did our homeostatic speed dating. I believe that was correct answer. Drifted off for a little while. Yep, A and B. So we know they're sensory, and then they are the afferent pathway. The efferent pathway causes an effect with the effectors. So if it's not motor, then it must be sensory, so it has to be afferent, not efferent. So these are the afferent neurons, the afferent pathway. And then these, of course, are going to be efferent. You've already had to address that in last week's cutaneous lab. It asks about a lot about afferent, efferent. All right, now this was stuff that we covered last week. Had to do, whoops, move this out of the way. Yeah. There we go. Okay. This had to do with summation. So spatial summation refers to what? You have multiple graded potentials originating from different locations simultaneously, repeated graded potentials reaching the trigger zone one after the other. Supra-threshold potentials triggering action potentials that are extra large, electrical signals reaching neurons from outer space, or all of the above.
Definitely all of the above.
Including outer space. Okay. Again, there's a challenge to come up with the distractor questions, and sometimes spatial, outer space. there's just flipping his book like crazy. Let's put him to use. Let's make him useful. $199. Oh, further along than I thought. There we go. Thank you. Oh. Oh. So are you saying that your brain has limited hard drive space? Not enough RAM, that's the problem. Not enough random access memory.
Yeah, I'm about to just.
You can't have enough windows open. Just like an old computer.
Yeah, I need that code typed in.
Yeah.
Max, you know.
Well, we just need a little memory card.
There you go.
Need to upgrade your memory. Ooh, I really have to think about this one.
And makes it worse, I didn't bring my glasses today.
Did you drive here?
Yeah.
Hey, people, on the way home, you need to find out what car John's driving and drive behind it. Or get around it quickly. Of course, that could be John's. I don't know. Have you answered yet? Okay. Oh, there we go. Of course, I stopped paying attention, but I know that B's not the right answer. A is the right answer. All right. First of all, what is summation? Because there were a bunch of people that were a little lost out there. What does summation mean? What's happening? Okay, there's a book definition. It means that the neuron cell body dendrites has got multiple synapses from other neurons. And they are needed to bring that membrane up to action potential threshold. So a single fire from one of those neurons onto our desired neuron is not enough to change the membrane enough to get it to minus 55 by the time we get to the axon hillock. So to sum is to increase with multiple firings so that we get builds, and then we get enough change that we can get an action potential to occur. So now we have two ways that the brain's going to handle it. One is to have that single neuron fire rapidly, and that's increasing in time, temporal. Or another option is to have more than one neuron firing at the same time. And that's spatial, because now we have multiple spaces taken by the presynaptic neurons. So that's why A is the correct answer. Okay, this one can't be right. Why is this one wrong? What was wrong with this part right there? What's wrong with that? What do we know about action potentials?
They have a little threshold.
Okay, there's a threshold, but there is no such thing as super. There's no such thing as extra large. An action potential goes to plus 30 millivolts, period. Cannot go any higher than plus 30. So that one makes that one wrong. Okay, that one I made up. Okay, this one can't be right because it includes a made up one. That, you know, was just a little extra ridiculous. Of course, I don't know, Southeast Oklahoma, y'all do believe in Bigfoot. So you might believe in aliens too, I don't know. So really, your choice was between these two. This one is temporal summation. This one is spatial because it's more than one space. All right, now what about this for terminology? Now here we have the case where, oops, move out of the way. The period after an initial stimulus when a neuron is not sensitive to another stimulus at all. So the period after the initial stimulus which means I just crossed off one of those, by the way, with that first phrase. When a neuron is not sensitive to another stimulus at all, there's a special term that's used for that condition. I should probably mark my roll. Okay. We're struggling with this because it's new terms. Haven't had time to soak in, percolate yet. Yes. I think that was right. Again, I stopped looking. Yep, absolute refractory period. So that's called the absolute refractory period, when a neuron cannot receive another stimulus. John's got his book for